So, we're going to get started on the next part. Basically, here we discuss why are we doing geometry in the first place. So, we're doing geometry because we want to be sure that the screen you're watching this on or the pencil you might be holding in your hand are what they are, that they are the shapes we believe they are, because sometimes something looks like a square, but it's not really a square. Maybe it's a rhombus, or maybe it's a rectangle, and we got to be sure about things. And the way we're going to do that is with logic. It is our tool. We have two main types of logic at our disposal. Two main types. Now, we got inductive logic. Inductive logic. It works by observing examples of something being true and then concluding that it is true. Its weakness is that, well, let me show you the example. I've got a guy standing next to a parking garage. Not a great drawing. And he's looking at the cars coming out. Now this guy, he's got amnesia. Incredible amnesia. His amnesia makes it so that he forgets everything that happens in the last, 5 minutes. So he doesn't remember anything. Not one thing. He barely remembers himself. So he looks at the parking garage and he sees, oh look, here's a car. Now, because I don't have red available, this time I'm going to make it a black car. And in fact, he sees 5 black cars, 5 of these. And then he concludes every car must be black, no matter what. And this is what inductive logic does. He looks at the multiple examples of the cars coming out of the garage, and then he says, oh, because this is the only thing I'm seeing, that's the truth right there, that there are only this type of car. Now, obviously, we know that this is not true, that there are more than one color of cars, but in his mind right now, there's only black cars. Only black cars. So, that's what inductive logic does. It looks at examples and it comes to conclusions. Its weakness is rare exceptions. Like, he sees 5 black cars, but who knows, maybe the 10th car was going to be another color. Its weakness is rare exceptions. So the thing is, that's what we're talking about when we say, is that square? Is your phone basically a square? Is it a rectangle? Is it what you think it is? We're worried about rare exceptions. We're worried about things not working exactly the way we think they are. Now, since inductive logic is very, very limited in math, we're going to use deductive logic. Deductive logic works a little bit differently. It works by saying when A is B and B is C, then A is also C. You may have seen it somewhere. If A equals B and B equals C, then A equals C. And so basically, I just have to know these two things in the first place, and then I can come to this conclusion pretty easily. It makes sense too. Now, what's the weakness of that though? Why wouldn't it ever equal? Why wouldn't A ever equal C? Well, the weakness is false assumptions. Maybe, just maybe, A didn't actually equal B. What if that happened? Then, well, it's not actually true that A equals C. Maybe B equals C, but A didn't actually equal B, so A didn't actually equal C. And so, if that's not true, then we're in trouble. We have to limit our assumptions. Limit them as much as we can. We find out in geometry, they started off with 5 assumptions, basically. We have, I would say, about 20, but, and I haven't counted them because they become a little bit too much to count. But we limit them to that many because we don't want to be caught in a bad situation like this. And it's very difficult to trace an error like this too. In any case, in geometry, we use deductive logic. We use deductive logic. But that means that we need a few assumptions to get started.